So today's lesson is on tree diagrams, a little bit different than Venn diagrams. So what we're doing is we're listing all the different possibilities that you can have visually. And so, for example, this is going to be like the probability of A. And so if A happens, we're going to follow this path. If A does not happen, so the probability of not A, we're going to follow this path. Okay, so that can be like literally anything, right? The probability that it's raining, the probability that it's not raining, right? The probability that you have $20, the probability that you don't have $20, so on and so forth, okay? Then after that, we have the probability of B here, right? And in this case, on the bottom, we have the probability of not B, not B. And we'll do actual examples so that way you can see it. But if you follow the not raining path or the not having $20 path, let's just say, then you have another scenario here, and again you have probability of B and the probability of not B. Okay. And so to find out the total outcome, right, like if you follow this path right here, what you're doing is you're taking the probability of A and multiplying it by the probability of B. Okay. If you're taking this path right here, you're doing the probability of A times the ooh, times the probability of not B, right? Because we're going here, here. And I think you get the idea, but I'll just go ahead and finish this for you, times the probability of, I keep wanting to put parentheses because of times probability of B, and then this one right here is the probability of not A, and, right, multiply the probability of not B. Okay, you notice I had to pause there just to make sure. All right, so what does this really look like? So you're riding to school on a particularly unreliable bicycle. The probability that you have a flat tire on a given day is 0.4. Wow, that's a lot. That's 40%, right? If you have a flat tire, the probability of you being late to school is 0.9. If you do not have a flat tire, the probability of you being late to school is 0.3, okay? So we have two scenarios here. We have the probability of flat, right? And the probability of not flat. And then the second factor that we have is whether you're late to school or not. So this is the probability of late. This is the probability of not late, right? This is the probability of late. This is the probability of not late. All right, so now we're putting some numbers in. So it says the probability that you have a flat tire on a given day is 0.4. So the probability of flat here is 0.4. That means that this right here, we can do this right off the bat because this has to add up to 1, is going to be 0.6 because 1 minus 0.4 is 0.6. Okay, all right. So now let's take the second scenario. If you have a flat tire, so now we're following this path, the probability of you being late to school is 0.9. So this right here is going to be 0.9 because this is if you're late. So that means that this one by default is going to be 0.1 because again, this has to add up to 1 whole. All right, we're cooking with gas. If you do not have a flat tire, right, so now we have this path, the probability of you being late to school is 0.3. So this is going to be 0.3, and the probability of you not being late to school is going to be 0.7. Yeah, that's a lot. All right. So now let's answer the question. So given that you are late to school, okay, so we know that we're going to be late to school. So it's going to be this. Let me just go ahead and change the color real quick. So this is what we're looking for, right? Late to school, late to school. It's going to be one of these. What is the probability that you had a flat tire? So that means that we know that we're going to be following, right, the path that you had, given that you were late to school, the probability that you had a flat tire. So let's go ahead and notate this, right? So the probability of you have a flat tire given that you're late. Remember the word given, right? So how do we do that, right? We do the probability of, look back at the formula booklet, flat tire and late over the probability of late, okay? So the total late. So now let's go ahead and put this in, right? So the probability that we have a flat tire and we're late, right? So that's, we're going to follow this path right here. So we're taking these two numbers and we're going to be multiplying it. So we get 0.4 times 0.9 on the top, which is 0.36, which you can solve in a second, and then the probability of late. So the total late, right? We have to take these two uh, pads and we have to add them together. So let's go ahead and figure this out right here. So this one is 0.36. And all I'm doing is I'm multiplying this, and if I follow this path right here, I have 0.4 times 0.1, so this path is going to be 0.04. If I follow this path right here, I have 0.6 times 0.3, which is going to be 0.18, and if I follow this path right here, 0.6 times 0.7, this path is going to give me 0.42. Okay, all right, so now we're going to take our probability of late, right? So this is this path right here. So let me go ahead and just check this path, the probability of late, and then I'm going to add that to the probability of this one, right? If you don't have a flat and you're late, don't have a flat and late. So this is going to be 0.36, right? Plus 0.18, 0.18. Okay, so now let's go ahead and solve this. So we have 0.36 on the top, and then 0.36 plus 0.18, and this becomes a calculator question. Hit enter in the calculator and you get 0.667. Okay, rounded to three significant figures. So, and the reason why we did that is because we used the word given. Okay, given that you were late to school, what is the probability that you had a flat tire? All right, so these are some more explanations, another problem here, so go through that first and then try these here. Good luck.